Hello and welcome to the Beyond Biotech podcast number 121. I'm Jim Cornwall and this is the weekly podcast from Labiotech. A little bit of a departure this week as we're talking to a biological control biotech company that is looking to beat mosquito-borne diseases such as malaria and dengue fever. The company, Oxitec, recently launched a new platform called Sparks to limit mosquitoes' ability to transmit dengue fever. To tell us a bit more about mosquito-borne diseases and how biotech can help stop them in their tracks, our guest on the podcast this week is the CEO of Oxitec, Gray Franson. So I guess the first thing then would be as if you could give us a bit of background on the company.
Yeah, Oxitec is a UK-based company that spun out of Oxford University in the early 2000s. And over the last 2 decades, we have built a remarkable platform powered by amazing people. The company itself was built really to solve the big challenges associated with managing dangerous mosquitoes and harmful pests in the agricultural space. And over the years, we've developed really a platform now that can build multiple technologies and deploy those technologies globally. We are made up of a team of hundreds of people around the world from 15, 16 different countries. And really, at this very important stage of the company's life, we are now moving technologies to the field at scale commercially, where we are having a true impact, especially on things like dengue.
So does the Ox in Oxitec, is that because of Oxford?
Yeah, the original name was Oxford Insect Technology. And it just stuck. So Oxitec is our primary brand, and then we have multiple product lines, of course, with different branding.
I guess a lot of people are going to know about the various forms of malaria and dengue and some other mosquito-borne diseases. Could you maybe highlight what the problem is and some of the stats related to the prevalence of those diseases and how that's maybe worsening in some places?
Yes, certainly. Well, I think most of your listeners will no doubt know about malaria and dengue, but many people do not realize that the fight against these diseases has either stalled or is beginning to backslide. So malaria, for example, really is the most devastating and deadly vector-borne disease on the planet. It covers, major parts of the planet. And, we're close to 250 million cases of malaria every year. In 2022, 619,000 people died, and most of those who died were children under 5. Africa is the single most burdened region/continent in the world, and that accounts for probably 96% of the global burden of malaria. Dengue is also terrible, and right now is a real emerging threat in new parts of the world. So the headlines on dengue have really begun to change dramatically over the last few years. And I'll talk about that about why in a minute. But dengue itself infects over 400 million people a year. So while it's not as deadly as malaria, it impacts more people. And it will cause in the ballpark of 40,000 deaths in a given year. And 100 million people will suffer from, what is called breakbone fever. And that is a debilitating, painful experience over a number of days or weeks. When you bring these two things together, we look at the vector-borne disease landscape with a sense of urgency, because in the case of malaria, we're seeing a culmination of things that are really threatening our progress in the fight against malaria to get to elimination. And the same is with dengue. On the malaria front, we are suffering from a couple of things. One is the typical vector control tools that we're using are losing effectiveness. So mosquitoes quickly generate resistance to any of the major classes of chemical pesticides that we use. And because we use them over and over and over again, mosquitoes engineer themselves around it. Second is, across the African continent, certainly, urbanization is still happening at an accelerated pace. So cities are still growing very, very quickly. And what we have seen in the last decade is the introduction of a new invasive malaria spreading mosquito called Anopheles stevensii. And that mosquito has come through Djibouti and is now throughout the Horn of Africa. And it has now spread through Central and parts of West Africa, where we're starting to pick this thing up. Why am I talking about that one particular mosquito? It's because it is responsible, and it will be responsible for opening up a new front in the war against malaria. Most malaria is transmitted in rural areas, and that is where most tools have been focused, and we've built tools for those rural engagements. But in cities, with an invasive mosquito that loves to live in and around complex urban environments, and given the fact that it bites during the day, typical tools aren't working, and governments are desperate to find solutions for it.
Is climate change having an effect insofar as is it extending or changing the geographical distribution of these species?
Yes. So I would argue climate change is really one of the biggest drivers of the expansion of the mosquito that transmits dengue, Aedes aegypti. And arguably dengue is a real poster child for the types of devastating health impacts that are resulting from climate change. So maybe put more simply, as the planet warms, the habitat in which this mosquito thrives is spreading. It's spreading north and south. And that means now that parts of Europe are suffering from dengue vectors, wherein it had previously been absent. North America, the Aedes aegypti and Aedes albopictus, two dengue vectors are marching north at an alarming rate, which means when you take that around the planet, billions more people are now impacted or threatened by the potential for these disease transmissions. And malaria is very similar. That invasive mosquito I just talked about, that is driving into cities because of urbanization, but also because of changing climate patterns. And thus, we need to take a very different, very starkly different approach.
Is that in some way, I know it's not a good thing, but is it in some way a good thing on the basis of the fact that it's always been considered to be kind of a tropical thing and it's not affecting Europe and the US, but now that it is it maybe going to mean that it's taken more seriously?
I think, sadly, that is the case. Even in my 24 years of work in places like Africa, in conflict zones and areas where these diseases are prevalent, the Western world and the Northern Hemisphere has viewed these diseases as very remote, as something that happens, over there or far away across the ocean. And that just simply isn't the case anymore. And I guess the silver lining here is that as some of this disease impact hits these new constituencies begin caring. And as that starts to happen, but the potential for mobilizing more resources for a global response is increased. And I say that with specific focus on Washington, on Brussels, on London, and some other important capitals where we know big decisions are made that oftentimes can spell out whether or not we're going to make progress in a given period of time against these critical diseases. So yes, silver lining, it's unfortunate, but we have to make the best of it now.
Could you explain the Wolbachia replacement technology and why that is effective?
Yeah, we are really proud of the fact that we have now launched a new initiative that we're calling Sparks on the Oxitec platform that is going to begin scaling up what is called Wolbachia replacement technology, or the Wolbachia approach. And the approach itself is actually quite brilliant. It's genius. The people who began working on this are exceptionally smart, and we owe them a great debt of gratitude. They figured out that if you take a certain naturally occurring bacterium from one particular insect species and you transmit that bacteria into an Aedes aegypti mosquito, that bacteria effectively blocks the ability for that female mosquito to transmit the dengue virus. The bacteria itself is naturally occurring in 60% of insects globally. It's harmless. It has no impact on humans, animals, or the environment. And when we stop a female mosquito's ability to transmit diseases, we see disease rates go down. And over the last couple of decades, this technology has been developed. It's been proven by university groups and nonprofits. And about 2 years ago, members of the public health community and I started talking about whether or not Oxitec could bring its expertise in scale up and large scale deployments, professional manufacturing, to Wolbachia such that we can make it available to millions and millions more people at a faster and faster pace. And thankfully, the Gates Foundation agreed, and we've launched a new partnership that we announced a few weeks ago, wherein the foundation is providing us financial support to rapidly build out the capacity to build these mosquitoes infected with this bacteria and to move them out into the market as quickly as we can.
So what is Sparks? Is that the program?
We came up with that name because, for us, it represents sparks of joy, sparks of hope, but also the idea that sparks can spread and sparks can spread goodness. And in the case of this technology, when you begin releasing mosquitoes infected with Wolbachia, it spreads that bacteria through the local wild type population. And therefore, it continues to expand the radius of impacted communities and prevents more and more females from transmitting dengue. Oxitec is developing technologies and in the case of Wolbachia, scaling new technologies that look very different than the tools we have been using for the last 100 years against these diseases. I try to make the point everywhere I can that given what we talked about, climate change, about rapid urbanization, about the loss of effectiveness of traditional tools, what we are doing is no longer novel. What we're doing is needed. And I think the shift we've seen over the last even few years at Oxitec, as the first movers, as the pioneers in this space, the phone is ringing more and more from governments calling us to urge us to deploy in their regions. And the way we're looking at this is we have an imperative to advance these technologies to the field as fast as we can. And when we think about how different these are from big drums of chemical pesticides with a skull and crossbones on it, on the side label, what we want to do is empower communities to use these new safe technologies. So Oxitec's mosquitoes are arguably one of the most powerful vector suppression tools in the world, but they're completely safe. Safe to animals, to the environment, to sensitive ecosystems, of course, to humans. And if we're going to generate trust amongst communities that we seek to serve, such that these tools can be used effectively, we need to create an interactivity and a completely new interaction that people have with this type of technology. So Sparks and a number of our other product brands, I always want to reflect the exact opposite of what chemical pesticides do. So we're not calling them doom or boom, no lightning rods with dead, mosquito images on the can. We want to create something beautiful and inspiring, and so far it's working really well.
Very good news. Yeah, are there other companies using similar technologies to this?
Behind us, there are a few good organizations out there working on various parts of the mosquito problem. Some groups are using different genetic engineering technologies or CRISPR. All of them are earlier stage than Oxitec, but it is refreshing to see that now we're not the only ones. We've been the only ones for a long time, and now to see other groups watch us and generate confidence that we're creating space for an ecosystem to start emerging. I'm both proud of that, I think, on behalf of our team, but I'm also really thankful because we can't solve dengue alone. But it also means that we're not going to be the only ones working with regulators or with the range of stakeholders needed to carry out this important work.
Does what you're doing differ from groups like the World Mosquito Program?
So the World Mosquito Program is an Australian-based or derived organization coming out of Monash University. It's a nonprofit, and they've done outstanding work on the Wolbachia front. So the technology we talked about earlier, Wolbachia replacement technology, really has been advanced most by the World Mosquito Program to this point. And so all of us have a great debt of gratitude for the good work that they've done. Importantly, they carried out a really important epidemiological study in Indonesia. And I won't bore you with the details in relation to how we show that any of these technologies work, because that gets quite lengthy and is extensive in nature. But WMP, as they call themselves, just did some outstanding work to demonstrate in health terms, human health terms, that by releasing mosquitoes with Wolbachia, we can see a dramatic reduction in dengue. So their work is exceptionally important. Given that the Gates Foundation has chosen us to begin scaling the technology, we really look forward to working with WMP and with other Wolbachia innovators as we begin ramping up production.
How quickly does this take effect, once they're released into the wild?
The mosquitoes get to work right away, of course, but on the Wolbachia front, establishment, as it's called, so multiple releases of infected mosquitoes into an environment, establishment can be seen typically over a course of months. You would want to see sustained releases for at least that period of time, at which point we would envision or hope that establishment has taken place and that bacterium load in that area will be there for a number of years.
And you already mentioned, I think, that there's no real effect on food webs or anything like that.
It's a good question, Jim, and it's the right question when you think about either altering a local wild type population or eliminating a certain type of species from the environment. And I will say maybe I'll take both of those. So Wolbachia is not designed to kill mosquitoes. This particular type of Wolbachia is designed to replace the population with female population incapable of transmitting dengue. And so the change that Wolbachia has or makes in the environment is harmless. On the suppression side, so on, say, Oxitec's friendly mosquitoes, that technology is designed to kill mosquitoes. It's designed to suppress over a period of time the biting female or the disease-transmitting female population. And when you deploy that technology into a community or into a city, it rapidly and dramatically suppresses the population. And in that instance, back to your question, when we remove Aedes aegypti out of the environment, we do have to ask ourselves, what would the impact be on things like bats and bees and frogs and snakes and fish, of course, all the way up the food web. And the case with Aedes aegypti is that it is an invasive species almost everywhere it is. And so when we come and take that particular species out, it really has no impact on the environment. And we answer that question for regulators every time we submit a dossier to enter a new country. And to date, we've built a significant body of knowledge and research and peer-reviewed literature that highlights exactly the point that we're not having any long-term or deleterious impact on humans, animals, or the environment.
And we've seen it with COVID changing rapidly over a space of months. Is there a potential for adaptation to cause the technology to be ineffective?
On the suppression side, so Oxitec's friendly mosquitoes, no, because we release only males, and when they mate with wild-type females, all female progeny die. So we're killing off the ability for any real genetic alterations or resistance to exist. And we've demonstrated this over the last 20 years, scientifically, empirically, and both in the lab and in the field. On the Wolbachia side, it's slightly more complicated, but in general, once we have established Wolbachia in a community, we do not expect to see any deleterious impact. I'll just step back and think, even 10 years ago, the only things we had in our arsenal were chemical pesticides that do what to the natural environment? Completely have an impact on every living thing in the area of application. Now, it's not to say chemical pesticides have no role today or tomorrow, but I think this next generation of technologies that we're advancing really do draw a very stark contrast between what is now possible and what has been used to date. It's a marked shift. It's a really big shift. And arguably, I would say in the last 100 years, this is going to be the most fundamental shift, moving from chemicals only to biological interventions that are both highly effective, surgical in nature, species specific, and completely harmless. That's a big change.
You mentioned the Wolbachia doesn't kill and the friendly does. Are they being used in tandem, and how does the relationship work there?
Love that question. Yeah, and so I think for your listeners, most of us, when we think about mosquito control, we think about killing mosquitoes. We just talked about Wolbachia, and that's a slightly different, modality. And yes, when you think about effective interventions with Wolbachia replacement technology, you can imagine that the lower the mosquito population in a treatment area, the faster you can establish Wolbachia in that particular area. And thus we are going to be working on a few different operational research elements that will allow us to evaluate how best to combine our mosquito technology, Oxitec's core mosquito technology, and Wolbachia interventions. But on the Wolbachia front, the suppress and replace concept is definitely supported by academic modeling, by scientific experts that have been thinking quite a bit about this subject. I love the idea, personally, I love the idea of bringing to the fore the right mix of technologies or solutions such that we can get rid of the problem. And I think the neat thing about Oxitec is that we're building out a very robust portfolio of a range of interventions that allow us to create economies of scale, to create efficiencies in the development process. And now, as we are seeing with our commercial operations in Brazil, the expertise necessary to actually commercialize these things so they can have impact. So the hybrid question is really cool. And I think we take a very pragmatic view in that our mosquitoes are transformational in nature. And that necessitates us to think about all the things around that transformation and that really innovative shift, which is where I spend a lot of time thinking.
You mentioned earlier the two different species of mosquito, the Anopheles stevensii and Aedes aegypti. Did the technologies that you use work differently in any way on the two different species?
The Oxitec gene technology is the same in both our Aedes aegypti and the Anopheles stevensii. And that's really one of the magical things about our technology, and that is it can be used in any number of species. It's a very stable, proven system for making helpful adaptations to the mosquito's genome such that all female progeny die after matings. And so we benefit from that. Same technology goes into both of these two very different mosquitoes. The effects are the same. The performance profiles should be the same. We're still early with our Anopheles stevensii effort. Just a month ago, we moved into field trials in Djibouti. So we have teams out there right now going door to door, engaging, deploying mosquitoes, working with communities to start establishing our first sets of data in relation to how we characterize that particular product. So it's very exciting.
In terms of rollout, how do you do that? I mean, how do you decide on coverage areas and the timing and the numbers that you're going to require in any one given area?
Yeah, that's a really, really good question as well. Maybe a couple of guiding principles that we use. First, I think for your listeners, Oxitec doesn't go anywhere uninvited. We are only operational in areas where governments and communities have asked us to come and help. And so I'll give you the story about Djibouti and Anopheles stevensii. I shared earlier, Anopheles stevensii is an invasive, it's a very, very dangerous and very alarming new malaria threat. And it really does almost single-handedly or single-wingedly maybe pose a threat to the entire headline of the malaria fight. As in, this thing, once it moves into African cities, is going to spread malaria to many, many, many more people. And that could ultimately tip us backwards and and start a backslide of progress, which would be devastating. So in 2018, the government of Djibouti approached us and asked if we might think about helping them with their Anopheles stevensii problem. Djibouti is a small country in the Horn of Africa. It is a major port city, an entry place for a lot of trade that comes in and out of Africa and the Middle East. In 2012, they had reached near elimination with malaria. So down to, only a handful of cases, literally, sub 100 cases of malaria. And then this Anopheles stevensii mosquito came into the country, and within a very short time, they were experiencing 60, 70,000 cases. And that's alarming. It's alarming to them. And they came to us because chemical pesticides aren't working. Anopheles stevensii have developed resistance to all of the major chemical pesticide classes. And again, as I mentioned, it's a daytime biter, so bed nets don't work. It's an outside biter, so indoor residual spraying doesn't work. So we put our heads together with the Djiboutians, and we got to work on building an Oxitec-friendly Anopheles stevensii. What we do when we prepare to move it, after we've built it, and we do most of the work on biology in the UK, just outside of Oxford. And when we begin moving it to the field, we do a few things. First, of course, we're there because government wants us. We begin engaging communities arm in arm with governments, door to door, at the farmers market, at social functions, anywhere people are. Our team is there engaging, listening, educating, and building trust with communities. Our technical teams begin designing field pilots that will, in essence, allow us to show regulators and the scientific community, the public health community, that our mosquitoes behave just like wild-type mosquitoes. They mate with wild-type mosquitoes. They are 100% female lethal, meaning when our males mate with wild-type females, all female progeny die, and that over time, we can generate a suppression effect to a significant degree. Once those trials are done, we petition a government for a commercial approval so that we can get moving on actual interventions, real interventions at scale. And to your question, to do that, to design interventions, we use a number of factors, but maybe just the most simple, I think, that we can all appreciate is the fact that we need to know in general what the load of the mosquito population is in that particular area, how many Anopheles stevensii are there, because that allows us to adjust dosing. We need to know how many release points and where those release points for our just add water kind of egg release devices might be. We need to have a general sense of weather. Mosquitoes are very picky as it relates to weather. And in this case, we want to get a head start before a mosquito season. So when do we start deploying such that we have our males in the environment ready to capture as many matings with wild-type females possible? And then we get to work. We begin deploying and we begin monitoring and surveilling our performance. And we will calibrate or adjust our deployment methods or dosing based on data that starts coming in. And by the end, we take stock and evaluate how much suppression could we achieve and what can we do better for the next season.
Do you need to keep doing this on a seasonal basis?
The answer is yes. Just like chemical pesticides or bed nets, we have to continue to fight the enemy. The enemy will continue to try to return and entrench itself and sustain itself in these environments. So with Oxitec technology, unlike chemical pesticides, there is no resistance that is created to it. So what happens is when we begin interventions, we dramatically suppress the population. And the next season, we can use lower dosing because the population won't bounce back. And over time, we move down to a very low dosing level where it's really just a maintenance application to keep a certain population at bay. So it's very elegant, it's very, very sustainable, and the profile of the performance over a couple of seasons is really favorable to the governments working to use the technology.
You mentioned earlier that the Gates Foundation was helping with some of this. Are there any limitations in some areas based on cost? And I guess connected with that also, if you're trying to eradicate from an area, in Africa as an example, there are politically sensitive areas where there are wars going on. And how do you manage the fact that you want to eradicate it, but there may be geographies that aren't conducive to that?
It's definitely the case that in many places where these technologies are needed the most, there is the least ability to pay. And that is a real challenge in the public health arena, in malaria and in dengue in particular, where many communities are dependent on international donor agencies or external funding, where governments haven't chosen to prioritize malaria or dengue control, or where there simply is not a means to control it. It is troubling for us. And I think at Oxitec, we think about that every day. We think about how to build our technologies, our solutions in a manner that drives cost to the lowest possible point, such that we can cover as many people as possible. I spend a lot of time in capitals advocating for larger amounts of funding being devoted or dedicated to public health interventions of these types. And as an innovator in this space, Oxitec has kind of the twin responsibility of breaking new ground and showing what's possible with these types of technologies, this next generation of technologies, while also advocating very strongly for the rest of the world to catch up. Because now that we have these technologies and that they have been proven, we need the ecosystem within which we operate to innovate as well. That goes for regulators upgrading their systems such that they can rapidly do risk assessments for technologies of this type. We need modernization in donor communities where paperwork can be cut, red tape can be slashed, decisions on funding for new innovations can be made faster. We need to modernize how, frankly, the World Health Organization organizes itself for the evaluation of these technologies such that it can make recommendations. Right now, the WHO has what many call an outdated system for evaluating new malaria or dengue control technologies, which prevents endorsements from the WHO that governments need to access funding from donor agencies. And we get in this kind of doom loop where it's almost impossible for Oxitec or others to carry out the types of things that WHO might want to see. And yet the technology is available, ready, working, proven. And the WHO teams working on these items are very sensitized to this. They're doing their best to modernize systems. My point is, not to beat up on WHO, our technology is here now. It's ready for impact. It is having impact, and we want to do it at scale. We need the rest of the ecosystem within which we operate to modernize along with us. And so I spend a lot of time thinking about that, talking about that, working with other groups to harmonize what's possible now that we're here.
Is this a technology that could be applicable to other insect-borne diseases or even kind of animal to human diseases?
So Oxitec is working on a range of very fascinating challenges in the public health space. So we have, we're focused on mosquitoes, on a number of mosquito species that are affecting populations around the world. But we're also, and it's less known, that we are working on a range of agricultural pests and livestock pests. And our smart teams are engineering new solutions that will, for example, help control cattle tick, or the Asian blue tick, which is one of the livestock industry's most devastating pests. And I'll just connect the dots to a bit of what we talked about earlier, Jim, and that is in this era of rapid climate change and a desperate need for us to move to a more sustainable posture on this planet, the beef industry is a really important player. It is an important force and will have an outsized impact on whether or not we can achieve certain sustainability targets in the near future that are really important. And while I professionally haven't thought a lot about beef up until this point, I've been more focused on eliminating malaria in our lifetime. We started turning our attention to the beef industry because there are major headwinds for really a range of livestock kind of industries in relation to pests that are generating resistance to chemical pesticides, the same stuff we're seeing in mosquitoes. And the challenge with that is to sustain beef production efficiencies. More and more chemical pesticides are being used. And again, they're becoming less and less effective as a result. So there are harmful effects of using chemical pesticides, increased costs, and still ultimately a reduction in beef yield. So why am I droning on about beef here? If we cannot make beef production more efficient in the near future, we're going to have a hard time hitting certain sustainability goals. And I think the only way we're going to be able to get more beef per animal is by creating new pest control solutions that help. So that's not to judge good or bad the beef industry, of course, but we're really interested because there's a direct line between us helping the beef industry use sustainable tools such that their impact on the planet becomes less and less, ideally. So that's just one example of how we're looking pretty expansively at the sustainability spectrum and are evaluating where we can have an outsized impact when we build a certain solution for big problems. And that's just one example.
Are there any other areas of diseases that you're working on?
In terms of human diseases, we really are focused on malaria, dengue, Zika, chikungunya, yellow fever, and a few others. We are taking a look at EEE. We have a team that looks at these certain pests to evaluate whether or not we, Oxitec, can really have an impact. And we're taking a hard look at the vectors of EEE because it's a complicated disease because there are a few species that transmit it. And, I think we're just getting started. There are plant diseases. So we haven't really talked about agriculture, but, the same thing relating to the cattle industry is happening in the broadacre or the row crop space in horticulture, where pests are coming in hard, existing tools don't work, yields go down, inputs go up, prices go up, and negative impact on an ecosystem goes up. So it's really, we're kind of in a losing formula right now as it relates to pest management and the need for more food to be produced per square kilometer. The headlines are not taking us in that direction. So Oxitec chooses the big projects. We want to be working on issues that are going to have a major impact. And we are asked, I would argue, maybe once a week sometimes, about whether or not we can tackle a given pest. We'll get a call from an industry or a country And in most instances, we say no because it wouldn't align with our mission or our values or with the fact that we're choosing the big problems to deal with. We have a window right now. Oxitec has a window. We have the team, we have the talent, we have the shareholders, we have the ecosystem and partners to lead this transition that I talked about. And if we don't take that opportunity in these next couple of years, I think the planet will be lesser for it. So we're just charged up, we're fired up, and we're moving.
It's important that in the race to beat certain diseases that the treatment or the solution doesn't end up damaging the planet. So it's great to talk to a company looking at the entire picture and coming up with some interesting and excellent solutions. Don't forget to check out the latest news and articles over at Labiotech.eu. And I hope wherever in the world you are, you have a great week ahead. Thanks for listening. And I hope you'll join us again next time for another Beyond Biotech.